Hey friends, and welcome to our chapter review, full chapter review. I've said review lots of times. We're reviewing, in case you didn't catch that. Alrighty, so first thing we did in chapter 2 was just take a percent of a number. So for example, if we have what is 37% of 146. Okay, just taking a percent of a number. Most of our story problems are like that. And in order to do that, we change the percent to a decimal. So we move the decimal place over 2 places. Woo. And so that becomes 0.37 of means times 146, and 0.37 times 146 is 54.02. Taking a percent of a number. There we go. The next section was estimating percents, and really this is one of the most useful ones just because estimating is useful. For lots of reasons. Just remember, 50% is half. 25% is half of half. To find 10%, move the decimal place over 1 to the left. And 1% is move the decimal over 2 to the left. Okay, so for instance, we can estimate, I don't know, this is what happens when I'm trying to make up numbers on the spot. Estimate, let's say 27% of 32. Sure. Okay, so 27%, I would round that. Let's see if we can find 25% in our brains. We could even round 32 to 30 if we wanted to, but I don't know that we need to. So I'd take half of 32, which 2 goes into 3 one time with 1 left over. 2 goes into 12 6 times. So 50% is 16, and then we take half of that, and it's 8. So our estimate of 27% of 32 is about 8. If we calculate it for real, 0.27 times 32, we get 8.64. So our estimate right on target. Stay on target. All right, the next section, we worked with the percent proportion and the percent equation. So, and honestly, you are welcome to use either one as you're solving for things. Totes don't care as long as you get the answer right. So remember, the percent proportion is the part over the whole equals the percent over 100. By putting the percent over 100, that's the same thing as changing to the decimal form of the percent when we do that. And so this way we don't have to deal with decimals, which is kind of nice, especially if you're solid on your cross multiplying, which you should be from last chapter. Then if you remember the percent equation, anytime you have the part, really, this is the percent equation up here, right? So if we have, let's try a different set of numbers. What percent of 300 is 96? Question mark. Okay, so remember we've got the percent. We want to have a whole, and usually it's next to the word of. It's on the same side of the is as the percent, and so in this case the 300 is the whole and the 96 is the part. That's the one that's by itself on the side by is. Remember, is the equal sign in math. Remember, of is multiplying. Okay, so because we're not algebraing yet, we can either put these numbers into the percent proportion. So we put the part over the whole equals the percent's what we're solving for over 100. Okay, now 2 ways to do this. You could also, if you're just going from the percent equation, remember that anytime we have the part, we can just do that division. And so we'd still, that's 300. 96 divided by 300. If we just do that division, 96 divided by 300, it gives us 0.32. Then we have to change it to a percent, 32%. Over here, if we do the percent proportion, we don't have to worry about changing decimals and percents. We'd do 9600, because 96 times 100 is 9600. And then we divide that by 300, and guess what, my friends? That comes out to be 32. So either way we do it, 32%. Okay? All right, that's percent proportion and percent equation. Again, the challenge is just making sure you know if you're solving for the whole or the part or the percent, or which ones you have. Okay? Awesome. Moving right along. Percent of change. Percent of change. Remember, this is when a number is changing from something to something else. And so we're going to find the difference, which means subtract. And we want the absolute value of it, which we want the positive. And then the answer to that subtraction problem, we divide by the original. Okay, and then it's always good to say whether it's an increase, which means it gets bigger, or a decrease, which means it gets smaller. Okay, so for example, the infamous, like, on the test, you don't even really, there aren't even stories, it's just numbers. So let's say we have, oh, I know, while I was driving over the weekend, they had a statistic up on the boards that they can change over the freeway. And it said last year over the Thanksgiving holiday, as something like, I don't know, 30 people passed away. Oops, sorry about the announcement.
This is Mrs. Lyons, just reminding teachers who want to do the TikTok dance that we're in the choir room. We'll be filming in about 5 minutes.
Welcome to life after school or during school. Anyway, the 30 people lost their lives on the roads over Thanksgiving weekend last year, and this year only 16 people did. And so that's a horrible statistic to deal with, but I mean, it made me think for a minute. And so we find the difference, which would be 14, and we divide by the original. Man, my pencil is struggling today. Okay, and so we know it's close to 50%, but let's get the exact 46.7%. And did it get bigger or smaller? It got smaller. Okay, but then my question was, how many fewer people traveled on Thanksgiving weekend because of quarantine? So, I don't know, it was numbers to use. Sorry if that was a little depressing. Okay, so percent of change. Find the difference, divide by the original, or the first one listed. Okay, tax tip and markup. I feel like we've practiced a ton, but just remember with tax, tip, and mark up, we can either add the percent, take the percent of something that's over 100, or we find the percent and then add it in. So, for example, we buy something that is $46 and the tax is 6.7%. If we're just make sure you answer the question, because if it wants the total, that's when we want to add in the percent. If it just wants to know what the tax is, we just take that percent. Does that make sense? Okay, but in this case, we're looking for the total. So we can either change the percent to a decimal, and that becomes 0.067, times 46, 0.067 times 46, and that gives us $3.08, which we would then add into the $46, and altogether we're paying $49.08. If you want to do it the adding the percent way, we want 100% of the 46 plus the 6.7 in tax, which is 106.7%. Change that to a decimal, and we'll do 1.067 times 46, and that should get us right to what we got doing it the other way. See, 49, well, and I rounded, so we didn't have the 2. 49.08. Okay. And then the last thing we need to remember is, let's do discount. We've practiced that so much. There's tons of those discount practice questions on the last set of, so I'm not super worried about that. Let's remember PERT. Interest equals the principal times the rate times the time. And what's the big thing we need to remember? The time needs to be in years. I've been pretty nice about the years on the test, I think, so it shouldn't be too bad. So let's say we want to calculate the interest if I deposit $1,000 into a savings account that has a savings rate of 2.3%, and I leave it there for 2 years. Okay, so we really just put all these into the formula. Interest equals the principal, which is 1,000, times the rate. We have to change that to a decimal over 2 places, so 0.023. And there again. It's weird. Times 2 years, and then we literally just put that in the calculator. 1,000 times 0.023 times 2 years. And in 2 years, you get 46 free monies. Okay, so if you don't deposit anything else in there, that means the total amount in your account, if it asks, they're all just asking for the interest. So you're good to go. If it does ask, it means total in there would be $1,046 if you haven't deposited anything else. Okay, and that is chapter 2 in a nutshell. Good luck with the practice test. Let me know if you have any questions.